In section 5, we will cover a task that involves building a powerful image classifier using transfer learning. Transfer learning is the process of taking something trained on one dataset and using it to make or help make predictions on a different but similar dataset. We will leverage the features of TensorFlow 2 while building a project in which we will implement a competitive classifier for a Kaggle dataset by leveraging the advantages of transfer learning. In this video, we will talk about an introduction to transfer learning in TensorFlow 2. The idea behind transfer learning is to train a neural network on a big dataset of images that are as diverse as possible. This network should then learn a good representation of most images and should therefore be usable for any kind of classification task, even if the kind of images we want to classify were not part of the original training data. We can take advantage of the general features learned from the initial dataset so that we don't have to start our training from scratch. This will, hopefully, make training much faster while maintaining good classification quality. There are some caveats, however. You cannot directly use an entire network trained to classify cars for classifying shoes, for example. You still need to do some training, but you can use the first layers of the network trained on cars, which hopefully have learned enough general lower-level features to still be useful. By only having to train a few layers, training time will be reduced considerably. Another downside is that this approach sometimes works great, but other times classification accuracy can noticeably suffer, making the process lose its usefulness. In TensorFlow, the way this works is by using a pre-trained network and freezing some layers, usually the starting convolutional layers. This will mean that these layers won't get trained when training the entire model on our new data, obtaining the speedups we mentioned previously. We will see how to do this in the next videos.